Good morning, everyone. I, Samir Kumar, welcome you all to my today's class of physical science. This is our fifth class, and this class is going to be a very interesting class. So, let's start our today's class without any further delay. Right? So, just observe this picture. I'll ask you a question after you have observed this picture for 5 seconds. Okay, so how many of you guys have actually been to a swimming pool or have ever swum in like water bodies? Okay, that's a significant much. So I will ask you a question that when you go for a swim, so do you feel heavier or do you feel lighter when you are in water? Yes, students, right. You feel lighter. Okay, so now you see in this picture there is an empty bottle placed inside the water body. It is also floating. So why is it floating, students? Yes, this is going to be our topic for now. We will be studying why you feel lighter in a water body and why this bottle floats. Okay, students? So let me tell you that this all happens due to a phenomenon called buoyancy. Okay, students? So let's see what is buoyancy. So buoyancy is a force, buoyant force is a force that is applied by the water body. So we can say when an object is placed in water, it experiences an upward force on that object, right? And that makes the object lighter. Okay, students? So when an object is placed in water, it experiences an upward force on that object that makes that object lighter. This upward force is called as the buoyant force, or we can say upthrust force. Okay, students? So let's take the example of this bottle only, right? So this bottle, what is up? How? Which forces are being applied here? We can say that the weight is being applied in this direction. We can write it as mg. Mg is the weight, but this weight is being countered by another thing, and that we can say this weight is being countered by another thing, another force, and that force is being applied in opposite direction, right? That force is being applied in the opposite direction, and this force we can say as buoyant force, or we can also say it as upthrust force, right? We can also say it as upthrust force. Very good, students. So now let's proceed ahead. Okay, students, now we have a quiz for you. So just read the first question. The first question is, what do you mean by buoyancy? Try to answer this question, students. Yes. So we say that when an object is placed in water, it experiences an upward force on it, right? And that force makes it lighter. The force is called as the buoyant force, and this phenomena is called as buoyancy, right? Okay, students. So now there is the second question for you. The second question reads, the empty bottles floats in water bodies because of what? The empty bottles floats in water bodies because of because of right. It floats in water bodies because of buoyant force. Or we can say it as upthrust force. Right? Okay. So now let's proceed ahead. Yes, students. So now let's proceed forward. Okay. So you might have saw that the ships that are made of iron often floats in water, right? But a small, simple, humble nail, when you drop it in water, it sinks down, right? So let's see at this picture now. Okay, we have placed some nail in water also and a piece of cork in water also, right? So we saw that the nail sinks down but the cork floats. So what is the reason behind it? Okay, so we will be learning this. Okay, we will be learning the reason for floating and sinking, right? So let's take the first instance, that of the nail. We know that the nail sinks, right? The nail sinks. And why it sinks? So let's check it out, okay? So we are seeing that the nail is being acted upon by the force of gravity, which is equal to the mass of the nail times gravity, right? So the force of mg is acting on this nail, right? But the upthrust that the water must produce to keep the nail floating is not so much, right? So let's say buoyant force is fb and the weight is denoted by Fw. So we can say that force due to the weight or mass is more than the force due to buoyancy. So in this case, what we can say? We can say that the nail will sink, right? The nail will sink, right? Now let's see the example of cork. The cork floats, okay, right? This happens because of their density, right? Because the density of the cork is less, so the matter contained inside it is less, right? So what is happening? This density, this less density is happening the cork to float in the water. Okay, students? Right. So what is density? So density is defined as mass per unit volume, or we can write D equals to m times m divided by v. Okay, so d equals to m divided by v. Okay, right. So the density of cork is less than that of the water, right? And this means that the upthrust on the water on cork is greater than the weight of the cork, right? So it floats, right? We saw in the case of nail that the force of buoyancy was less than the weight of the nail, right? So density of the cork is less, right? So there is less material, there is less mass, so its weight will be also less. And in the case of cork, what will be there? Force of buoyancy. Force of buoyancy, we can denote it as Fb, will be more than the weight. Okay, so the force of buoyancy will be more than the weight, and as a result, what will happen? As a result, the cork will float, right? The cork will float. Okay, so now let's proceed ahead. We have saw that we are comparing the density of cork to that of the water. Okay, students? So what is the relative density, right? So the density of iron nail is more than that of water. That's why it's saying, right? So this means that the upthrust of water on the nail, iron nail, is less than the weight of the nail. So it sinks. So to find out, we will see a term called the relative density, right? So what is relative density, students? Relative density is the density of any substance compared to the density of water. Okay, students? So what is relative density? Relative density is the density of any substance compared to the density of water. Okay, students? Right. So now let's proceed ahead. Okay, so there is a quiz for you, and the quiz is which of these will float on water. So first option is wood, second option is cork, third option is iron, and fourth option is both A and B. So just think about this question for 10 minutes, then I will ask you about the answer. Okay, so what will be the answer, students? Right, it will be both A and B. Let me change the color of the ink. Should be right. It should be both A and B, right? Because the wood will float, cork will float, iron will sink, right? So the correct answer is both A and B. Now, students, tell me what is the relative density, right? So I'm giving you 10 seconds. Just think about it. What is relative density? Okay, so we can say that relative density is the, we can write it as RD. RD equals to density of the substance compared to the density of the water, right? So it is the density of any substance compared to the density of water. So that is relative density. So now let's proceed ahead. Right. What can you see in this picture, students? It is a biography of a very famous scientist, very famous mathematician, engineer, physicist, philosopher, astronomer. Right. So his name was Archimedes. Right. His name is Archimedes, and he was born in the year 287 BC. Right. He was born in Greece. He died around 212th century BC at the age of 75. He is Greek mathematician, engineer, inventor, physicist and astronomer. Okay students, now let's see what is his contribution, why we are studying him in our today's class. Okay students, right. Okay, students. So we saw about the Archimedes. So why we are studying him in this class, right? So let's see this picture. Let's see this picture. Okay? So what you can see in this picture, students, that there is a spring balance here, right? This is the spring balance, and we are trying to put this weight down in this water, right? Now we have immersed this weight in the water. Now what is happening? The water has flown out, right? It has rose in the level and then it has flown outside in this tumbler, right? Okay, but now we see in this spring the object that was weighing 4 Newton is just weighing 1 Newton. Okay, but the difference in the weight is being recorded here, right, in the volume of the water that is displaced, right? So based upon these observations, Archimedes stated some principle, right? And the principle what he stated is that the upward buoyant force that is exerted on the body, the upward buoyant force that is exerted on the body immersed in a fluid, whether partially or fully, is equal to the weight of the fluid that the body displaces, right? So to put it in simple terms, we can say that the buoyant force that will be applied to the body will be equal to the weight of the water or the fluid that is being displaced by that body, right? So that is the Archimedes principle, right? And that Archimedes principle is very useful for us. We are applying this Archimedes principle even in our today's life. Okay, so let's see what are some applications of the Archimedes principle, right? So in designing ships and submarines, Archimedes principle is being used. Okay, so students, can you see here? Here is a cross section of a submarine, right? When the submarine has to submerge down, it fills its ballast tank with water. So what happens, students? The weight becomes more and the displacement is constant because the size of the ship will be not changing, right? So the displacement is the same and the weight becomes more and the ships submerged, right? The submarines get submerged. But when it has to surface, then what it does, it just removes water from its ballast tank. Then what happens? Air fills in it and the weight becomes less. As a result, the submarine surfaces. Okay, students? Right. You might have heard about an instrument called as the lactometer. So lactometers are used to determine the purity of the milk, right? Lactometer is used to determine the purity of the milk, and hydrometer is used to determine the density of the liquid. So this is also based upon the principle of Archimedes. Okay, students, right? So let's proceed ahead. There is a quiz for you. So the quiz is you need to state the Archimedes principle. Right, students? You can do it in a very simple language also. Right. I'm giving you 10 seconds to think about this question. Okay, right. So the Archimedes principle states that the buoyant force applied on a body will be equal to the fluid displaced by that body. Or we can write the force of buoyancy. Let me change the color of the ink. Right. So the force of buoyancy will be equal to the right. So the force applied by the buoyancy will be equal to the weight of the fluid displaced by the body. Right. So now students read this question. Give the uses of Archimedes principle. Okay, students, just think about this question for 10 seconds. Then you can answer this question. Yes. So we saw that Archimedes principle is used to design ships and submarines still today, isn't it? We saw that it is used in manufacturing, used in the designing of ships and submarines, right? It is also used in lactometer, that is used to determine the purity of milk. It is also used in designing of hydrometers, right? So these are some examples or some uses of the Archimedes principle, right? So now let's move ahead. So in our today's class, students, we have studied about the Archimedes principle. Okay. So now let's quickly answer a few questions. So let's define buoyancy. So students, buoyancy is what? Buoyancy is the force applied by any fluid that upon the body that is being submerged into it. Right, students? So you need to explain now why the nail sinks but the core floats. Yes, students? Right. The nail sinks because the water displaced by the nail is less in comparison to the weight of the nail, so it sinks. But the core displaces more water than its weight, therefore it floats. Okay, students? Right. So, students, describe what is relative density. Yes. So, we can write relative density is density of any object compared to the density of water, right? So density of any object compared to the density of water is the relative density. Okay, students, right? So now let's state the Archimedes principle. Okay, students. Yes. So the Archimedes principle states that the buoyant force applied on a body will be equal to the amount of water or amount of fluid displaced by that body when it is placed in that fluid. Okay, students? Right. So, what are the three uses of the Archimedes principle? Who will tell me? Yes. So, first one is it is used in the designing of ships, right? It is used in hydrometers and also in the lactometers. right? So Archimedes principle is used in designing of ships, hydrometer and lactometer, right? So this is your homework. This is an activity rather. So you need to take a bucket and a mug. Start by putting water in the mug and fill it till it sinks in the bucket of water. Now you need to note your observation that how much amount did it take to really sink that in the bucket. Okay, students. So that's all for today. Have a nice day. I thank you all once again for attending my today's class.